be doing anything like coding, right? You'll not be doing anything like coding or anything like for a while, right? For a while. You can actually hold this class at least, let's say, for a week or two with your phone. You can comfortably join the class with your phone, right? For the next 2 weeks. And subsequently, right, you can still join with your phone. Like I said before, the idea is that when there will be need for you to do practical stuff, you can maybe reach out to your friends that have PC or go to any cyber cafe and just practicalize what we've already studied, right? Um, so today is majorly about your thinking model as a software engineer, right? This is what we'll be handling throughout this week and maybe into next week, right? Um, because the truth is that most people learn syntax, right? Syntax is just the what makes up a programming language, right? And so in this class, throughout this class, our focus will be on Go language, right? And we don't really need to maybe know much about Go language now. It's not really necessary, right? You can still do your research about Go language if you want to, but it's not really necessary in this our phase now, right? The idea is that at the end of this phase, right, you using programming languages as tools, right? You be using them as tools and not as the main thing, right? You be using programming languages as these are tools and resources you want to use to implement what you know as a back-end engineer, right? It cannot be like the main thing which most developers do, right? And so most people don't really understand what system design is, right? What system engineering is. They just want to build projects, and at the end of the day, you find out that they build stuff that will not last, or that don't really last, or don't really make sense. We are in an era of AI engineering and or AI world, right? Where AI can write codes, right? AI can do a whole lot of things, right? But at the end of the day, it still boils down to the developer. It still boils down to the engineer, right? If you don't have the correct mental model, if you don't have the right foundation of building a correct system, right, to know how data flows from point A to point B, from point B to point C, you will not know how to, you will not be a good engineer, you will not be a good developer. So being an engineer has less to do with code and more to do with how you reason, right? It has a lot to do with how you reason, how you reason logically at the end of the day. You get. So throughout this course, will be visiting or seeing some few Go snippets here and there. Like I said, the Go snippets are just the Go snippets are just uh, the Go snippets are just a preview, right? They are just something that I want to use to teach you what we are trying to talk about, right? So you'll be seeing some Go snippets, like some Go codes and people get, but don't think much about it at the end of the day. It will make sense when we start implementing it in a code base, right? But what we'll be doing majorly this period is just to define some vocabulary, some terminology, some usages in the back end world, and how data interact. So that's what we'll be learning throughout this course. But at the end of today, right, at the end of today, right, you should be able to look at an app or look at any app, right? It might be a backend app, it might be WhatsApp, it might be Uber, and you can be able to break it down like an engineer, right? So at the end of today, this is what you'll be coming up with. So at the end of today, you should be able to look at an application, right, from the eyes of an engineer. So you should be able to look at an application and break that application down into layers, into categories, right? So and I hope we achieve that goal today. I hope we achieve that goal today. And as much as possible, I want to beg you not to be distracted. Right. I want to beg you not to be distracted. Um, I'll be sharing my screen now. Like I said, at any point if you stop hearing me, just please indicate. Just indicate that you can't really hear me, and we'll definitely maybe know what to do. Right. So first of all, this is where we'll be starting from. Right. We will start from this definition, right? And this class will be interactive. I'll ask a lot of questions. I'll ask a lot of questions actually. Um, as we progress, I'll ask you questions. So I will want you to put your mind into this and think with me. Right? I want you to think, try and think with me. So as much as possible to break what needs to be broken down. Right? I'll try as much as possible to break it down. So that we be in the same page. Let me be sure that this is being recorded. Okay. So we'll start by defining what a program is. Right. If you can see my screen well, you can see the definition here. We say that a program is a deterministic set of instructions, right, executed by a computer. Right. Now, if you pick the words apart, right, we will understand that um what deterministic means is just that this is what is being known ahead of time. You can determine the outcome of something. Yeah, it's just that the outcome should be known ahead of time. Right? Based on the instruction, you should know what the outcome should look like. Right. So that's what a program means. And so I want to use a very basic example to illustrate this. Right. Now I want you to imagine a program like a recipe. Right. So you know what a recipe is.
Yes,
You know what a recipe is.
yes. I do. Correction.
Okay. You don't know. You don't know. You know.
I know what
Oh, okay. 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 So let's imagine something now. Let's create a scenario, right? So we are still trying to define or understand or drive this what a program means home, right? We want to drive it home and understand it basically what it means. Now, like I said before, all these concepts will come in handy as we progress. It will come in handy as we progress. These are components that you use and think to bring out a very good solution, right? And also, when it comes to let's say interviews, these are some of the things that you might be asked at the end of the day. Aside of maybe writing some code or logic, these are things, part of things you might be asked at the end of the day. So let's just create a scenario here. Let's say you are giving or I gave you a recipe of for jollof rice, right? Um, and the recipe contains what's the list here. You add oil, you add onions, you add tomatoes, and the list, right? Now,
yes.
if you follow it exactly, if you follow this recipe exactly as it is, you will get the same result every time, right? Like every time you bring out this recipe and decide to follow the instruction the way it is on the recipe book, you come out with the same result which is jollof rice, right? And so that's what computers do. They follow instruction exactly as you give them, right? But here is the difference, right? Here is actually what differentiates a computer to a normal human being, right? So human beings can guess.
Yeah.
For example, if I give you this recipe now, with this recipe, you can think, okay, maybe I should add fish to this, or I should add, like, you can actually guess something. Maybe think, okay, maybe there should be um red oil or ground oil here, or just something. You can guess, right? But when it comes to computers, right, computers don't have the ability to guess, right? Computers cannot guess. So if the instructions you gave them is unclear, the program will break, right? The output you're looking for, you will not get it. For example, let's say I don't know how to cook jollof rice, right? And which I don't really know how to cook that much, right? So let it be a secret between me and you. This thing will be recorded. It's being recorded. It's no longer a secret. But um I don't really know how to cook much, and I make a recipe for you, right? Now, this recipe, if I give it to you, you can maybe, while cooking, you can maybe know that, okay, we really need to add some components here that I didn't add in the list. Right? You can really get things to add. But if you're a computer that I gave you this thing as a computer, you will bring out an output the same way I gave it to you, and you end up not producing jollof rice. And so that's what we mean when we say that a program is a deterministic. When we say that a program is a deterministic set of instructions executed by a computer, right? And we say that what you gave the computer is what it will bring out for you, right? Computer doesn't guess or try to adjust things. It just gives you your input. Do you understand? So
Mm.
in Go language, this is an example of a Go snippet, right? This is what a basic Go code looks like, right? And this is what we call function main. And this is kind of the entry level of Go. This is where the execution starts. Now, I'll try to link it up with this example here. Please, if you're confused at any point, just call my attention back. I'm here for you to explain this thing to you very well. Okay. Now, when I say that this is where Go starts executing, right? The function main, this is called function main or main function, anyhow you want to put it. But when you start executing Go code, the machine will start from, we look for this file, we look for this function, main function, and start executing from there. Right? Now, how does it link up with this our recipe? Now, this recipe has add oil, add onion, and add tomatoes, right? Now, where execution starts for this recipe now, assuming you gave it to a computer, will be from this add oil. The computer will not jump add oil and start executing this. It will not work, right? It will not jump this first one and start executing this. And so the way Go language works is that this is where the execution starts. This is where you start cooking your food. You're cooking your jollof rice. Using the jollof rice example, this is where you start executing. The computer starts executing your program, right, to give you the deterministic result you're looking for. Now, I want to throw this question at you, right? Um,
Mm.
if or how will I put this? So let's say that is a written recipe for jollof rice a program? Is a question
A
I'm asking.
written,
Giving the example,
a,
is a written recipe for jollof rice a program? Given the definition of what we said there, that a program is a deterministic
set of execution by
instruction executed by computer, and the illustration we gave,
yes.
right? So this is where I'm asking you now the question: is a written recipe for the low price a program? Huh?
Yes, in a way, it's program. Yes.
Why did you say yes?
Since the program is a set of instructions, I feel the recipe is a set of instructions too. This is similar to the computer program. So you can do a program, it's program, the step-by-step instructions.
Okay. Okay, you're correct. You're correct.
Yes.
So the recipe is just the rough recipe is a program. It's an instruction. So a program is just an instruction. It's just giving somebody an instruction of what to do. So if somebody say write a program for me, what the person is saying is just write an instruction for me that is deterministic. So it can be, let's say, build a bank for me, build a bank that holds money for me. Is this is you writing a program for it, is you giving a computer an instruction. Now, for computers, the computers don't really understand this normal English we are speaking, right? They understand programming
Mm.
language, right? And so Go is a programming language. The other programming language out there, right? Go is a programming language. We have Rust, we have C++, we have Python, we have Java, we have TypeScript, we have JavaScript, like a lot of programming language, right? But computers only understand programming language. So when somebody tells you, build a program for me, or I built a program, what should come at the back of your mind is that these people actually wrote a programming instruction that should do something, that should provide a certain output. Do you understand?
Yes, ma'am.
Uh-huh. So, moving forward, now, moving forward, you want to define and explain another term, right? Now, this is called input, process, and output. I want you to pay close attention here, right? Now, this is one of the most important ideas in software engineering, right? Because for every system, no matter how complex the system is, even if it's okay, even if it's one application at all, any application at all, whatever the application is, right? It can be broken down into these three components, which is input, process, and output. And now, when we talk about an input, what do we mean? We are saying that um, this system or this computer received an instruction, or we say that we are talking about what comes into this system or what you put inside of this system, right? And a process is what the system does with the information you gave it, right? And so we are saying that an input is just an information you gave to your system, while a process is the the way or what the system does with the information you gave it, and output is basically um, the outcome of the process of the input you gave the system. Now, let's calm down and explain this a little bit further. Let's go back to our Go code here. So this is an example of a Go code, right? Now Go language was written by Google, right? So these are one of the maybe basic stuff which we still touch when we start looking at Go mainland. Now this is a Go snippet, Now, based on this thing, what is happening here is that this function, this is a function, fn function, and the name of the function is add. The first one we looked at is main function. So there can only, now let me just say this in the pattern so that you will not be confused about it. So there can only be only one main function. Why? Because this is where it should start. This is where program should start running. This is where your system should start running, right? And don't worry, we'll still look at this thing in detail when we start talking about the Go syntax and how to run programs in Go. Right? But let's focus on this input process and output. Now, the input here we are looking at is that this adds accepts two parameters, right? You can think of parameters as placeholders, and you can think of placeholders as I don't know. Let me just draw this. Okay. So I wanted to draw some things for you to illustrate. Okay, so I wanted to draw some things for you to illustrate this thing. But let's just write in this box here so that you move a little bit faster. So when we talk about parameters, this is not our main focus, but Ashan, let me say it so that maybe you get to understand what you're talking about. So we said that this add function here holds two parameters, which is A and B. Right, forget about this for now. Forget about this ins for now. Forget about this for now. Just assuming that they don't exist. Focus on this A and B. So this add function accepts A and B as parameters. And so, like I said, parameters are just placeholders, right? And so this A can be any number, right? It can be 3, it can be 4, it can be whatever, right? And these parameters also have a calculation here, which is addition of A and B. And so the input here is A and B, and the processing here is the addition of A and B. Let me come again. Now, input, like I said before, from this definition, input is what an instruction you gave to your computer, an instruction you gave to your system, right? Process is now what the system does with the instruction you gave it. And output is what comes out from the process that the computer receives from your input. Now, let's go back to this place again, to this guy, right? So I said, forget about this integer here, forget about these two integer, these two stuff here, forget about, just imagine they don't exist. Imagine that this one doesn't also exist. Right, let's just focus on this A and B. So this A and B, look at it as inputs, right? So we gave this function A and B as inputs, and we told the function to calculate A and B, so to add A and B. And now, what is the input here? The input here is A and B. And what is the process here? The process here is the addition of A and B. So the process here now is the plus, because plus, what plus is doing is that is adding these two individuals together to produce an output. Does it make sense?
Yes.
Okay. Uh, okay. Now, I was checking my laptop percentage. I will soon go and on my lights. Now, let's actually talk about processes a little bit. Right? When we talk about process, we are talking about transformation. We are talking about that, let's still go back to our now. Remember, we are still trying to explain input, process, and output. Pay close attention. Let's go back to our recipe example when we are talking about programs, right? So let's use this. Do you have a question?
No, not yet.
Okay. So let's use this recipe to explain what input, process, and output means. Now, when you want to cook, right, the instruction or the inputs are add oil, add onions, and add tomatoes. These are the inputs, right? These are the input. These are the things you give to the pot, or you give to the pot actually. You give to the fire, right? And the process now will be what the pot does with the tomatoes, onions, and oil. That's what's the process now will be like, mixing them, adding them, turning it together, adding salt. These are all processes. And what will the outcome look like? The outcome will be that you have a jollof rice, right? And so the input is oil, onions, and tomatoes. The process is to the end that it will transform the input to a deterministic output, which in our case here is jollof rice. Does it make sense?
Yes. Yes, sir.
Okay. Um. Now, I want to ask you a question actually. All right. Maybe I'll throw the question to you also. So, and I want you to think through the question while I go put on my light actually. Now, when you go to a food delivery app, right? Have you used a food delivery app before?
Not really,
Okay. Have you
but
used
from
I
over.
should go on with, but let me use something you can relate with. Have you booked an Uber before?
Yes.
Okay. So now let's use an Uber to illustrate this. So when you book an Uber, right? Um, I want you to think about this. What is the input? What is the input of you booking an Uber? What is the process, and what is the output? Now, I want you to calm down and think through this. Okay. Let me on my lights, please. Just think through the example. Do you get the question?
Yes, I do.
Just think through it. I'm coming. So have you gotten an answer?
Yes, I have an idea.
So what's the idea?
Okay, so what happens with the input, process, and output will be that, so this is what I give to the Uber app, like my details, uh, or rather first the request for the ride. So that's the input. First things first, the request for the ride, my details,
Continue.
destination. Those are the level. All are the things I'm going to the computer. So the Uber first. And the process would be them um the what the system does, like you said, which is it has to um reconfirm my ride, send me a driver, and ask for my payment method depending on the app. That's what it's going to do for the process. These are the things it will do for the process. Then for the output, that is the final. Okay, final and choosing my output. The ride has been confirmed. I'm done with the ride. You know what the output will do. That's the value of my input and the process. So I've said about the input and the process. I get that. My output is like the result I should get after everything. The ride was completed. I think that's
Remember, we said that process transforms to a new output, right? So the input is what you give, an instruction you give to a system. The process, it will take the input and process it, transforms it into a new output. Do you get?
It's just the output now because I get the input and the process. So the output is the result I got now from the input and the output, sorry, and the process. Which I'm saying is the complete, I mean, the completion of the ride to be my output.
Is in you, you're not really confident with your answer.
No, I don't really get it. I, you know, I feel there are more, but I just know only that the the trip, the ride, sorry, completed to be my output. That's the what I say. That's the value of my payment. Of the
Yes. Now you got it right. Actually, you got it right. You got it right. You got it right. They don't have anywhere they used to clap for somebody. For clap for you. I'm so sorry. Um.
Hey. Mhm.
Okay. So just to reiterate, right? So what happens with the flow I just gave you is very simple, right? The Like you said, the booking of the ride is the input because you're giving an instruction, you're requesting for something, you're looking for something, you're giving an instruction to a system, right? So this system comprises of both the app you're booking from and a physical vehicle. Do you get? So a system is just components that come together to form a wholesome part, right? That's what a system is. And so these are coming together to just give you a very specific output. Do you understand? Now, the
Yeah.
process will be that the driver accepted, or after the whole payment, after booking your ride, the driver maybe accepted and know the whole process, came to your location, picked you from your location, dropped you where you want to go. Now, what happened between where you are standing and before you get to your destination is the process. Now, you getting to your destination is the output. Now, the output, what is an output? Output based on based on our definition
Awesome.
here is an outcome, right? Is what comes out of the process, right? The final result, right? That's what an outcome looks like. Now, now this this simple flow, right, is very very important. Now, times I've built projects that I really don't know what they are talking about. Like I'm saying that these projects I have no clue about them. What I needed to do is just to break down this project as mighty as it is, just break it down into input, process, and output, right? And so I know what data should be coming in. I know what data, when and what data should be processed, how it should be processed, and I know the exact output that is needed. That is enough for you to build your project. Do you understand? Now, I want to maybe let's try another project. I'm thinking of another project to to talk about now. Um, so have you um of course you use banking system to do transaction before, right?
Yes.
So now when you do a transaction, right? Or when you want to do a
Yes.
transaction, what is the input, what is the process, and what is the output?
I want to do a transaction in a banking app.
Yes, I'm talking about your banking app.
Banking app. The first thing I give is my information. That's the input. Like my card details, so I can log into the app. Yes, that's what I do as the input. Then for the process, it's what system does with the information they give to start to verify my if my logins are correct and correct, then log me into the system. Out that's the result of the input and the process. Maybe confirm my request, my payment, depending on what I want to do with the app. I should do my app.
Have you figured out the answer to the question?
Okay.
Huh?
What did you say, please?
I said, have you figured out the answer to the question I asked?
Yeah. Yes, I was already asking when the thing popped off. So I was saying that the input first I get is the information I'll provide the app with. These are my login first of all. Then the process is what the banking app or system does with the input I give. These are my which is confirming my or verifying my details. Then logging into the banking app. Why I do the things I want to do in the banking app. Then the output is what I is the value of the both the input and process. This is them confirming. Depends on what I think the app says. They'll confirm the payment transaction, then the confirmation is the output of process.
Okay. Now I want to say something actually. Um, when you log into your system or your banking application, right? You put in
Yeah.
your bank details, your login and your password, right?
Mhm.
Those on their own are inputs. And so what happens is that when you input those your credentials, the system try to verify, do a process, right? Processes it, right?
Mhm.
Your ID verifies that you're the one that is really logging in and you have the right access to log into the system, right? And you're the one that have the
Mhm.
dashboard you want to access, right? And now the result is that are you have access to your dashboard. You can see your bank details, you can see your bank balance, those stuff. Because
Mhm.
when we talk about output, we talk about the fact that there was something given in, right? There was a set of instruction you give. You want to access your platform. That was an instruction. Like the instruction is that I want to access my platform. Then the app went through a process to give you that outcome you're looking for. Do you get? Like we said,
Yeah.
and that's what at the end of the day, that's a program on its own. Because what is happening is that you're running a program that you know that the end goal is that you want to log into your system, right? So that's for that that explanation about input, process, and output. And I hope that is very, very clear. Because it will come in handy when you're building project, I promise you. It will come in handy. Even in real world applications, it will come in very, very handy. And now let's talk about this man here. States. All right. Um, states are very, very important. In fact, there are a whole lot of projects out there that we are built specifically for states only, right? And we want to decipher what states are and what they do, what they don't do, the whole process behind it, right? So that you understand state when you start working with back-end systems, when you want to collaborate with people, you understand what a state is and what is not and what it looks like, right? And so here we say that state is a data that persists over time. And so what do we mean by that? So when we talk about persistency, what do we mean? Like persistency is a normal English word, right? It can mean endurance, it can mean grit, right? It's just something that stays over time, that refuse to go up, right? And what is just trying to, the picture is trying to paint here is just that states are data, right? That are permanent but can be deleted. So I'm using the word permanent because even if you reload your web browser or you shut down your server, those states still exist. Don't worry about shutting down server and reloading your web browser. That is not really what you should be focusing on. Focus on what state is, right? Now, now, when we say that something is without state, or like let's say that when you say that a program, right, which we define that a program is an deterministic instruction given to a computer to run, right? When we say that a program is without state, what, right? When we say that a program has state, what do we really mean? Now, I want to use a comparison analogy here to explain what I'm trying to, or drive home what I'm trying to say. All right. So I want you to imagine and a a bank app. Right. So let's use a calculator and a bank app to explain it. So what we are trying to explain is what when we say that something, a program doesn't have a state or is stateless, which is the right word. What do we mean? And when we say that a program has a state, what do we mean? This is very, very important, right? And now let's use a basic calculator, to illustrate what um a stateless state looks like, or what a program being stateless look like. Now, a basic calculator does not remember the sum of its last output. Like when you um want to add something with your basic calculator, maybe you imputed 2 plus 2 and it gives you 4, right? Immediately it forgets that you're the one that asked that question. And so if you go back to the next minute and still want to ask that question again, it will automatically treat you as a new person. Like it will treat that information as is the first time of it receiving that 2 plus 2 from you. I'm saying that basic calculator doesn't know that your like such 2 plus 2 is equal to 4 have run before in that program. That's what stateless means. So that means that the data that 2 plus 2, which is a data. Remember now, if you want to actually not up what you've been talking about since, input and output. Now, the input here is that we gave the calculator 2 plus 2, right? Now the process is that the basic calculator wants to add that 2 plus 2 to output a result of 4 for you, right? And now the 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 process is the addition. The input you gave is the 2 plus 2, and the outcome is 4. Now, when we talk about statelessness, we mean that that 4, or the process of getting to that 4, and the input you imputed, the calculator doesn't hold account of it. It doesn't have any memory, or it doesn't store it anywhere, right? Like the right word is store. It doesn't store it anywhere, and so you cannot say, okay, let me just leave this thing here. Tomorrow I will come and finish it up, right? Or let me just leave the 4 plus 4 here and maybe add up another digit. Maybe later I'll come back to this 2 plus 2 and finish it up. Immediately you wipe that input from the screen of the calculator, it have wiped. Right? That's what stateless means. It doesn't, like, it can't hold information. That's what stateless means. And now when we talk about um state statefulness, right? We we were talking about states that information, that holds information over time, right? Let's use the bank app for example now. Now, when you come to a bank app, right, even if you log out, even if you delete the application, even if you sign out, whatever you do, provided you can reinstall that application, that bank app, put in your digits, you will always see the transaction you made in the past. You will always see your bank balance. You will always see the activities you did recently in the bank. That is what we call faithfulness. That's what we call persistency over time, right? In as much as you deleted the bank app, in as much as you wipe the bank app from your application, you can still have access to your data because those data are stateful. Those data are persisted over time. Does it make sense?
Yes, it is.
Thanks. Thanks so much. Now, let's use a Go snippet also to explain this a little bit. Now, this is a variable here. This is what we call a variable. Right? We talk about this later in this course. This is a variable, and this variable has um a name called balance, right? And it has a number or an integer. Now, I want you to forget about this for a moment and let's focus on this balance, right? We want to explain what states look like, right? And how Go language stores state. Now, Go language stores state inside of a variable, right? And so, like I defined variable before when I was talking about parameters, variables are placeholders. They hold information over time, right? They will persist information over time. That's what variables are. And excuse me. And now this is kind of a vivid explanation of how Go actually holds their information. I know that this thing doesn't make sense to you. I understand it doesn't make sense to you, but like I said, don't worry. Just I just want you to forget about that this exists. Let's focus on this. Now, this variable now is just a keyword in Go language, right? It's a keyword in Go language that if you want to store any data, you have to put in this var keyword. It's called variable for full, right? And var is just the short form. Then you can put in any name that you can use to remember the data you want to store, right? Balance, and maybe this balance will be your account balance, right? That's what it is. And so, and we are saying that states are data that can be predicted over time, right? And also, I should know that states are the hardest problems in software engineering, and that's why I'm taking my time to try to explain this for you so that you really understand what it is. Right? They are the hardest problem in software engineering. I want you to think with me a little bit. So I want you to think about a state now, like a notebook, right? Let's say this notebook is shared between your colleagues at work, right? So this notebook is what um any of your colleagues at work have access to, right? Just think with me. Now, if two people are trying to write, maybe write their new balance or maybe write the time they came to work, right? I think offices have that notebook where they normally write the attendance, the time they came to work, and all this stuff. I don't know if you guys have it, right? But if two people are trying to actually write the time they came to work at the same time, let's say Mr. A and Mr. B wants to write the time they came to work, and both of them are writing the time they came to work at the same time, that is chaotic. It's very, very chaotic because it is not is not reasonable, there is no coordination at all. So let's say 4 people are trying to um share the notebook at the same time. They want to update the notebook at the same time. Let's say that the notebook stops at number 10. Maybe number 10 is Mr. Adams that wrote his name last.
Mm.
Now, 3 other of your colleagues came in, and those 3 colleagues want to write their name at the same time. Like they 3 of them went and took pen and want to update their name at the same time in that notebook. That is a very bad state. Now, in that scenario, that notebook on its own is a state because it holds information, it holds data, it holds information of people that came to work. Does it make sense? And, and now, I don't know if this example is really making sense to you. Is it? Is it making sense to you?
Actually.
Partially.
Mm-hmm.
Okay. Don't worry. Calm down. I will explain it again to you. I mean, you need to understand what states are. You need to understand what states are. So we said that a state, uh, or the definition of a state is that is something that exists data, right? It holds data, right? Um, and we are trying to explain how that happens, right? And then we say that when what we try to explain what stateless means. We say that stateless means that this doesn't it cannot hold data, right? There is no way data can be held on it. So I want to use a very big example. I want to use a very big example. Okay, let's use the example. I think the example is this one. I think this example is this one. Now, uh, have you used a vending machine before?
Vending.
Eh?
Like,
Vending machine, those machines that if you put in money, you used it before, right?
I don't get it. Vending.
I mean, have you okay? Have you watched those movies, or have you seen a place a kind of it stands like a TV? So it sounds like a fridge, where people can put in money and they can select or they can choose a snack they want. Like you just put in money inside the slot and you can choose a snack you want. It's called a vending machine.
Mm. Okay.
It's
I have
but you have an idea of what it is, right?
yes,
Okay. I want you to just illustrate what you're talking about here. Now, you know, I'll still give some other examples, right? You know that when you go to that vending machine and put in your money and you choose a snack, right? And you get the snack you're looking for, right? If you come back the next time, the vending machine can never remember that you're the one that put in this money last, right? It can never remember that you're the one that put in this that took the last snacks from here. It doesn't have the capacity to remember that okay, this you are the one that just did the last information last from here. Right? That can happen on a vending machine. And that's what stateless looks like. Right? It doesn't hold information of what happened. You get now when we talk about stateful or stateful machines or stateful programs, the example that comes to my mind is I don't know if you have gone to a restaurant often. I don't know if you've gone to a restaurant often that um right? You came there, the woman will ask you,
Mhm.
is it your normal, is it your usual, or is it that system as so right? Is it like that kind of thing? You get now that is an example of stateful program. The man or the caterer, right, know what you want based on previous information or based on previous activity, and so that information they are working. That's what a state looks like. So a state what your previous an information of an activity that happened in the past. Does it make sense?
Again.
Don't worry. Don't worry. If it doesn't make sense yet, don't worry. Let me still use another example. Now, there are sometimes you go to a reception. Let's use a teller, right? Let's use a teller. You know what a teller is, right? Bank teller.
Yes, yes.
Uh, so when you go to banks, right? When you go to banks for
Mhm.
anything, right? And you go to the bank teller will request for your bank account number and your account ID, right? And so
Yes.
without without those information, you cannot have access to whatever you want to have access to, right? That's
Yes.
one. And after that activity, right? If you leave that place and come back to that teller again to ask for any information, that teller will still request for your ID and for your account details. That's what
Yes.
stateless means. That's what stateless means. It means that it doesn't it didn't hold your previous information, it didn't hold your ID and your account details that you used the first time. Right? It automatically forgets that you did something like this before. Because if it really held your details, the next time you come to that teller, the teller will not ask you for your ID and your account details. The teller should automatically know that, okay, you have done similar transaction before, or you've been here before, so I can attend to you. Do you understand?
Yes.
Does it really make sense?
Yes, it does.
Uh, so this is what stateless and state program looks like at its core. As its core. It might sound a little bit confusing, but it's important to know it. It's important to know it. I think this is where we draw the curtain for today. But before we do that, all right, before we do that, I want to show a question. The question is still based on this stateless and state programs, right? So,
Mhm.
is an ATM machine or an ATM actually a stateless or a stateful program? That's one. Now,
An
Google search
ATM
bar,
is
Google search bar, where you maybe search.
yes, yes.
I said, is an is ATM a stateful or a stateless program or stateless machine? That's one. Two, Google search, right? Where you search stuff. Is it stateless or stateful? That's the second question. Now, the third question is WhatsApp chats, where you chat and do your chatting and all those stuff. Is it stateless or stateful? So this is the three questions I want to ask you. I want to go and to give it to me, and we'll call it a day. We'll continue tomorrow.
Okay, today's question. The first one is the ATM machine. This doesn't hold ATM machine is a stateless program. It doesn't hold information. Second one, that's the city structure. City structure. This information. It's a stateless program. It doesn't hold information. Then WhatsApp. WhatsApp is where I don't really I might do to answer in WhatsApp. If I proceed for WhatsApp. WhatsApp is a stateless program.
Okay,
You
so
know,
why do you
WhatsApp. I'll come back to WhatsApp. Let me think more. I'll come back to WhatsApp because WhatsApp don't put information yet. Yes, WhatsApp
WhatsApp
was a
is a
yes.
stateless?
You can keep record of my information. WhatsApp record it. No, it's a faithful program. You just keep it. WhatsApp keep information.
Okay.
Yeah.
Now,
Keep my
why
record.
do you
You
say
can
that?
go back.
Why do you say that WhatsApp is stateful? Why do you say that Google search is stateless? Why do you say that ATM is stateless? Give me your reasons. Maybe one reason each.
For the ATM, you're not the only one that comes to the ATM. So, first, I just see that once you reach that point, you forget anything that has done previously. It's wiped completely. Then if you come back to it, you need to start after. That's what I think. That's what is stateless information. It doesn't hold the previous information. Then for the tax law will automatically pop up your previous your previous tax or something like that. You have to input it again to refresh or to bring out anything that you want. For WhatsApp is a stateful program. It does hold information for a long time, anytime. It stores
Okay.
information. That's the word.
Yeah, you got it right. You got it right. You got it right. You did a good job. So there's no clapping
Mm-hmm.
this thing. Yeah, I'm so sorry. I want to clap for you, but I can't.
Okay.
Okay.
Okay. Thank you.
Okay. So yeah, this is just the um summary of the but I think tomorrow I will maybe go a little bit deep into stateless and stateful. Now, I want you to maybe just cruise around stateless and stateful a bit and look at maybe talk research about how um or this is the research you want to do. We'll talk about it tomorrow. Can a program be stateless and stateful at the same time? Maybe just cruise around it. So we will talk about it, right? How a program.
Okay.
Yeah, so that's what we'll be talking about. We will start from there tomorrow. Right. Our time is already fast spent. And yeah. And so today basically what we talked about was that we define what a program is. We talked about input and output. We now talk about state. We now talked about state and what state means and what stateless means. To maybe go a little bit deep into state and stateless. Right. Then we now proceed from there. Um, that's all from me today. All right. And I want to encourage you, Sha, right? Is it might look a little bit tough, but at the end of the day, is rewarding, right? And knowing these basics first will arm you when you want to start writing code, because yeah, it will make code, it will make writing programs make sense to you, right? It will make writing programs make sense to you. And so that's why it's important for us to go into these details and understand what these things are and how they function. And I'll try as much as possible to see if I'll be breaking this down much more better to you. I'm trying. I'm so sorry, but I'm trying. But I'll try as much as possible to see how I can break it a little bit down to you so that we can be at the same page. Okay. That's that for me today.
Thank
We'll
you so much.
see tomorrow. Oh no, have a nice day.
Thank you. Thank you so much. You too. Bye.